Good afternoon, everyone. It's great to be here. Thank you for the invitation to Rework. And let me start actually with the question, who has heard of Wayfair? Well, okay, I'm always surprised when asked that question in Germany. No one has heard of it, so that's great. For the ones who didn't raise their hands, we are essentially selling furniture online. That's what we do. Cool, let's get into it. So my name is Rehm, or just Chris in short, and I will talk to you today how we at Wayfair started using Vertex AI and some tooling we've built around it. Cool. Some quick facts about me. My name is Christian, or just Chris. I'm a senior MLE in Wayfair, based in Berlin, Germany, and currently working on mainly two things. One is the infrastructure side, where I'm building Vertex AI for our team, and the other side is supply chain. Actually, also some interesting stuff where we're currently building model services in Rust. That's also fun. And I will be in town until Friday, so if you want to have a chat, here's my website, and you can find LinkedIn, everything. Send me a message, and then we can have a chat. Cool. So what will we talk about? First, I want to tell you a short story about Wayfair's cloud migration, which is a really new thing. And then we will jump straight into Vertex AI. So we will look at what is Vertex AI in general, and then sort of double-click on two services, which are Feature Store and Pipelines. And finally, in the end, we will look at what we at Wayfair built around Vertex AI to integrate that into our infrastructure, and to ease some pains that people would have. Cool. So in general, Wayfair. Wayfair exists for 20 years by now, actually. First under a different name. It got rebranded to Wayfair 10 years ago. But yeah, it's 20 years is a long time. So traditionally, we were completely on-premise. Now in 2019, we started to do the big undertaking of moving all of our infrastructure to the Google Cloud. That is finished just recently, like this year. All of Storefront runs in the cloud, and most of the other workflows as well. One thing we did as part of this was not only a lift and shift into the cloud, but also we took this as an opportunity to move away from like in-house built custom solutions and trying to leverage cloud native or some open source tools wherever possible. What are our experiences with this? So essentially, take this as from to, right? So from before 2019 to today. So we moved from on-prem to cloud. So we are trying to use as many cloud native services as possible. We shifted the thinking in a lot of areas from building our own in-house tooling to buying and sort of adapting like industry-proven solutions. Wayfair traditionally was building a lot of stuff in-house from scratch. This has shifted a lot in the recent years. We moved away from having our own data centers and central teams that manage infrastructure and shared platforms to giving autonomy to the atomic teams to have a more decentralized setup. So for example, we give atomic teams their own GCP projects, and yeah, that's just more autonomy. You don't have to, before you had to create a ticket to some team, get on the roadmap, wait for them to help you, and so on. So that improved a lot. And finally, the teams that previously used to dedicate their time to work on maintaining our infrastructure and supporting our in-house built platforms and products, they are now freed up to build innovation as opposed to spend most of their time just maintaining solutions. Cool. So this is the short context around where Wayfair currently is in the sort of infrastructure cloud world. And now let's take a quick look at Vertex AI. Vertex AI is Google's cloud-native end-to-end ML platform. The goal is sort of to offer you one centralized platform that has services to support the whole machine learning lifecycle from EDA through notebooks to training and serving. And so the sort of selling point here is the tight integration between all these services. So like it's sort of a network effect. The more you use of Vertex AI, the better the whole thing gets, right? So if you use the whole thing, for example, you can train, evaluate, and deploy a model without even leaving the web UI, right? It's like one-click deployment, all this cool stuff. But that requires you to invest heavily into all of these services. Now, Wayfair is not a new company, so we couldn't start from scratch, but rather had to see how we can integrate this piece by piece into our current infrastructure. Vertex offers two kinds of interfaces. One is for sort of more simple use cases, or I guess well-automated ones like AutoML or the one-click deployment I talked about, where you can go straight through the web UI. And the other one is to go through APIs and SDKs for programmatic access. Yeah, so just like SageMaker, what we heard before, it's completely serverless. So you don't have to worry about managing infrastructure. You offload all this responsibility to Google. You pay them a lot of money, but yeah, it's worth it. And one thing I want to point out in the end here, we heard this in previous talks as a downside of going with a vendor solution, so the vendor lock-in, and that is something to consider. However, we have actually pretty tight partnership and collaboration with the Vertex product team at Google. So we have regular catch-ups. We get some preview features to use before they get public, but also we give Google feedback and sort of real-world use cases at scale. So this works quite nicely. Cool. Quick rundown of our machine learning tech stack. So here, previously again means before going to the cloud. Now means, yeah, today essentially. So for the development environment, previously, as we were completely on-premise, we had virtual machines. So every employee had their own virtual machine, would log in there and essentially do everything manually. Now, at least for the scientists, we have Vertex AI Workbench, which is managed Jupyter with native integration into the platform. For packaging tools, back on the on-prem VMs, people would use Python virtual environments. It was not really standardized. Now we are essentially kind of trying to leverage Docker wherever possible, even for modeling. So we have a bunch of tooling around this where if you start developing a model from scratch using our templates, it comes with all the setup to give you a Docker image that you can deploy. For the data warehouse, we went from Vertica to GPQ. Orchestration, this one thing we'll talk a lot about later in this talk. We went from Airflow to Vertex pipelines, which is managed Kubeflow. Back in the day, actually, what we also did was to train the models directly on the Airflow cluster, which led to a lot of problems with resources and also noisy neighbor problems from different pipelines interfering with each other. Now we use Vertex AI training with completely separated execution environments. You deploy your Docker image and you train it in the cloud. For model serving, we traditionally just built our services using either Flask or Fast API in Python. Today, we are currently actually moving some of them to Vertex endpoints. Some others that have requirements that are not supported yet are still custom apps, either Python or Rust. And Feature Store, we actually didn't have one previously, and now we use Vertex Feature Store. Cool. Let's take a look at the Feature Store. Now, I didn't know that we'll have that many talks previous to mine that talk about Feature Store. So at this point, I would ask who is familiar with the concept of Feature Store, but I assume everyone is, at least now after the previous talks. So we can keep this brief. So Vertex AI Feature Store, just like any feature store, is a central repository for organizing, storing, and serving features for machine learning. It is a single unified solution that can be used for both offline, that is batch inference and model training use cases, as well as online use cases, so real-time serving. And it abstracts the complexity away from you to manage these two data stores and keep them in sync. This is in the end, so Vertex Feature Store is in the end doing exactly that, but the good thing is you don't have to worry about it. You sort of trust the service to take care of this. This way, like we heard previously, this will prevent training serving skew. That can happen if you have two different data stores for both offline and online use cases. The way that the data model is organized, so you have a feature store where you can have multiple within one project. Each feature store has then some entity types. These are essentially your entity, like your customer, supplier, things like this. And then each entity type has one to many features. So for a customer, for a marketing use case, it could be the value of your card, the average value of your card over the last week or something like this. And finally, Vertex Feature Store supports time travel. It's one of the kind of selling points here. We heard a lot about this in the previous talk. Yeah, essentially, it's a point-in-time lookup to prevent leakage. Yeah. We saw pretty much exactly this slide previously, so yeah, I mean, we can go quickly over it. So you have 2 points in time, T1 and T2. You have 3 features here, and you have 2 training labels, L1 and L2. These training labels are recorded at different times, namely T1 and T2, and you want to get the feature set for these timestamps and these entities. And you can go to Feature Store and give it essentially just a timestamp and an entity ID, so like a primary key of your entity, and it will take care of giving you exactly the feature values as of that point in time. So there's no leakage into the future. Cool. Next up, let's take a look at Vertex AI pipelines. Vertex AI pipelines is serverless workflow orchestration for machine learning workloads. This is essentially managed kubeflow. And yeah, I mean, it's an alternative to things like Airflow, Luigi, and so on. And yeah, so it runs the pipeline in isolated execution environments. So just like you would do with other Kubernetes applications. So they run in separated pods. And the nice thing that Google built on top of this, on top of Kubeflow, are some pre-built pipeline components. These are things to mainly integrate with other GCP services. For example, there is one that we use heavily that you can use to run queries on GPQ. And it abstracts a lot of complexity around building your own custom components away from you. So essentially, you give it a query, a project, and you do the authentication, and it runs your query and gives you the result. There are also other pre-built components for services like model registry to register your trained model, training itself, and so on. One nice thing about Kubeflow that we learned to appreciate coming from Airflow is that it treats pipelines as self-contained artifacts. So you compile your pipeline and the components to one big JSON file, and you can treat this as any other kind of artifact, so like a model artifact. What that means, what you can do is you can implement some MLOps process like continuous delivery just using this one JSON file. So you can move that around, you can deploy that. That makes things easy. Some other features of Vertex pipelines, yeah, so it's a decentralized execution environment. You will not have noisy neighbor problems. Each pipeline run is completely isolated from all the other ones. You have higher development velocity. This is at least true for Wayfair. For Airflow, we had quite the convoluted approval process for releases. Here, each team owns their own, GCP project and does the infrastructure and can very rapidly run experiments and ship changes. Yeah, and finally, it's extensible. So with the concept of pre-built components, there are other ones that Google is offering you, but you can also, and we do also offer some that we build within the company and can be used by other teams, so they don't have to build these components from scratch. So it's essentially like, you have a box of Lego bricks, you can assemble them together, and it works really nicely. Cool. Yeah, these were some quick introductions to Vertex AI and Feature Store and pipelines. And now let's take a look at what we built around this to make the life of our ML practitioners easier. So the problem. Our high-level goal essentially is to enable data scientists and ML practitioners to self-serve their orchestration and other kinds of infrastructure needs, to kind of take us as engineers out of the picture as much as possible and just enable rapid iterations and development. So we started the whole MLOps journey as part of our cloud migration around a year ago. At that point, we looked at Vertex, and we saw, okay, there is a Python SDK, but when taking a closer look, it became apparent it's really low level. Like, you can do things, but it's not as intuitive as we would have desired, especially if we want to have scientists use it and not only engineers. Also, it was really early on in the product life cycle, so there was some documentation was lacking, and for us as engineers, it required significant time investment to understand how the data model works, how we can essentially get this running in our own infrastructure. And finally we decided, okay, we don't want to tell scientists to become Kubeflow experts. Same as was mentioned in one of the previous talks. We thought the same. We thought scientists should instead focus on what they're super good at, which is building models. And so this left a gap, right? The tooling that was available was not up to the standard, but we wanted to get there, so we needed to do something. I want to point out that by now there is a new version of the Python SDK of Vertex, which is greatly improved. So if you want to use Vertex today, take a look at that one first. That may be all you need. 1 year ago, the situation was different. So we have a few solutions. Number one is we have built a shared library. We call this WF Vertex, Wayfair Vertex, which is essentially a Python library which is built on top of the Vertex SDK. And that offers some abstraction and sort of takes care of some of the integration complexity that is needed to get Vertex to run in our systems, which are not a greenfield, right? 20 years old company, so we have to get this to work somehow. We've built this from the beginning with the goal of having this as simple and as well documented for scientists as possible. And this is an ongoing development. So meanwhile, we have transferred this project to be inner sourced. So we have no central team owning this anymore, but rather we have contributors from across the company from different kinds of teams. And the thinking here that we want to establish in the company is if you are a user of these tools and you see there is a bug or there is a feature that you would love to have, please contribute. Right? So far it works great. The screenshot is like a month old. We had 18, I think now it's even more contributors. And as we keep developing this, for example, we had a team recently that wanted to start using Vertex endpoints. So we asked them, hey, please contribute some initial functionality, and then we can go from there. This is how it looks, for example, right, the operation to create a feature store. On the left, the big piece of code. This is how you would do it with the low-level Vertex Python SDK. So you see you have to instantiate a bunch of objects, the data model. Once you understand it, it kind of makes sense, but it takes a while to get there. And on the lower right, this is how you would do it with our library. Right? So it's essentially you instantiate the client once, and then you call the CRUD functions directly in there. You provided your project ID, region, feature store ID, number of online serving nodes, and that's it. One of the pre-built components that we are offering is for pipeline monitoring. Currently, Vertex Pipelines does not directly offer like alerting capabilities, but for production use case, obviously we need a good level of observability. At Wayfair, we use Datadog for that. So what we did is we built a pre-built Kubeflow component that is super easy to use. You can wrap your pipeline in it, and it will take care of sending your metrics to Datadog and all these things. And this is part of the library. How that looks is essentially like this. So you see here T1, T2, T3. These are your components, and the whole thing is your pipeline, so the Python function. The way that we offer the monitoring is essentially as a Python context manager. So it's super easy to use. You just need to put this with monitor pipeline, give it some tags, and that's it. What that will do, this will result in your pipeline being wrapped in this check status thingy on the right. And how that works is essentially it will run your pipeline, and whenever that exits, so this can be success or failure, it will send this status to Datadog, and then you can go there, set up your monitors, set up your alerts. That's it. Right. And then we did a second thing for the solution. Besides the shared library, we have set up a project template. We have an internal templating tool that's based on cookie cutter that's used across the company for all sorts of projects. So we added a Vertex pipelines template. And so now when you want to create a new project that is using Vertex pipelines, you can start from there. It will come with a completely set up CI/CD setup, linting, testing, a sample pipeline that you can immediately deploy. So, and we heard really great feedback from the scientists because what that means is, as a new user who never used pipelines before, you can generate a new project, you can immediately deploy it, a sample pipeline that's doing some batch inference, and you can start replacing things and sort of interactively figure out, how it works, plus we have the documentation. This is also part of the inner sourcing project we are doing. The main value in that is the CI/CD setup that we, again, as a scientist, you shouldn't have to care about these things. So when you generate a project using this template, it comes with linting, testing, building your Docker base image that is then used for pipelines. It will publish that image to Google Artifact Registry. It will compile your actual Vertex pipeline, deploy that to cloud storage. It will deploy the scheduling service. It automatically has already the logic in place to differentiate between dev and prod deployment. So all this stuff, which could get messy and just would cost a lot of time for scientists, you get for free. Right, so we're using BuildKite, by the way, for CI/CD. Cool. This is my big slide. So this is our complete MLOps infrastructure currently at Wayfair. Let's unpack it left to right, okay? So we have the IDE, could be a Jupyter notebook or whatever else you choose, and you push code to GitHub. In GitHub, you have your actual logic, so your scripts, you have your pipeline components, you have your Docker file that generates the base image that's used, you have tests, you have configuration. This is essentially everything you need to run. And you have also your BuildKite pipeline, so your CI/CD. Each push to BuildKite, including merging code, will automatically trigger a CI/CD run of our BuildKite pipelines. And these will do the things I showed previously. So they will do linting, testing, building things, releasing things. Particularly, the Docker image gets built and released to Artifact Registry. Also, it gets a reference to Vertex model registry. We compile the Kubeflow pipeline, push that to GCS. Cool. And then there's the final step where we create a cron job that gets deployed to Kubernetes to schedule things. Here I have to mention, this is something we would have loved to do differently. We would have loved to use Cloud Scheduler, so the cloud native scheduling service in GCP, but due to infrastructure restrictions, we couldn't. However, now we can. So this is one thing that will change really quickly. We're currently working on this. But the way that it currently works is, so you deploy the cron job, it runs in Kubernetes. You tell it to run on a set schedule, for example, daily. This will publish a message to Google PubSub. There is a cloud function that then listens to this topic, picks up this message, processes it, there's some configuration in it, and then this triggers the actual pipeline. So we also have a way to directly trigger pipelines from the CLI or Python code, but for production use cases where we want to automatically trigger, for example, training daily or have other triggers, we go through this PubSub cloud function pattern. Then the pipeline itself, it fetches your pipeline artifact that got compiled from GCS, fetches your model from the model registry, and your Docker image from Artifact registry. And this is all you need to run the pipeline. Then it depends on what the pipeline is doing. Yeah, so let's say it's training a model, so then you would go to GBQ and or feature store, fetch your data, do your processing, in the end push the model to Artifact registry again. It really depends on the use case. Everything that's sort of purple here is things we've built custom in Wayfair. Everything blue is Google services, and the application code, so the one thing that scientists and ML practitioners interact with, is all contained in GitHub, so the things with the orange circle around it. Everything else you get for free, don't have to worry about it. It works in the background. Okay, that is actually it. I have a short summary. So we started with this MLOps journey around a year ago. And yeah, we have settled for Vertex AI plus some internal tooling around it to offer abstraction and integration into our internal systems. And by now, so around a year since we started, it's used in production across many teams, including supply chain, fraud, scam, B2B, service intelligence, and a bunch of other ones. So yeah, there is good adoption, and we're really happy about this because that means we can continue building this out and making it even easier to use. Next up, we're working on a few things. So one is, of course, to onboard even further projects. So we want to get rid of Airflow, for example, completely. We want to work with our teams in the inner sourcing effort to iterate and improve the tooling even further. And finally, we're continuing to work with Google to integrate further capabilities as they get released into our tooling and make life of ML practitioners easier and easier. Some resources, we wrote 2 blog posts around this. There's a really great white paper from Google around like MLOps. There's some reference architectures here which we heavily took inspiration from, and the Vertex documentation. Thanks a lot.